The 787 Dreamliner was the first commercial aircraft with an airframe made of composite material that was not just lighter but more durable. Boeing claimed the aircraft was 20% more efficient to run than the outgoing 767.
A small mistake has grounded a fleet of 787 planes. In May 2025, KLM had to suddenly pull nearly 30% of its Boeing 787 Dreamliners from service due to a hidden fault, causing massive delays, stranded passengers, and serious fallout. There are concerns as to the root cause of the incidents. It could be due to Boeing's complex design or KLM's incompetence. So, how did such a critical error happen? And what exactly was the maintenance mistake that triggered this crisis? Join us as we look into the hidden fault in KLM Boeing 787. The hidden maintenance mistake grounding KLM's Dreamliners. In May 2025, KLM grounded 7 of its Boeing 787 Dreamliners after uncovering a critical maintenance error involving the aircraft's refueling system. Technicians had mistakenly applied maintenance procedures designed for the Boeing 777 to the 787 fleet.
KLM has grounded 7 of its 24 Boeing 787 aircraft due to technical concerns involving a refueling component. The airline clarified there is no safety risk but has ordered accelerated maintenance.
Although the two aircraft share some similar components, their designs and operational requirements differ significantly. This procedural oversight forced KLM to suddenly take out of service nearly 30% of its Dreamliner fleet, a drastic move that severely impacted its long-haul operations. Key international routes to destinations such as Mexico City, Chicago, and Portland faced cancellations and delays, disrupting travel plans for thousands of passengers. The grounding exposed how a single human error in following complex maintenance protocols could ripple across an entire airline's network, undermining both safety and reliability. How did this mistake happen? Stay tuned. What you're about to hear will blow your mind. The Boeing 787 Dreamliner is a significant leap in aviation technology. Unlike older models built largely from aluminum alloys, the 787's fuselage is primarily composed of ultra-light carbon composite materials. This innovation reduces weight, enhances fuel efficiency, and allows longer non-stop flights. However, these composite materials require specialized maintenance techniques, including advanced scanning to detect microcracks invisible to traditional inspection methods. Furthermore, the 787 replaces many conventional hydraulic systems with sophisticated high-voltage electrical systems that govern critical operations, including fuel management. By contrast, the Boeing 777 uses more traditional materials.
Okay, so why is fuel management so important? As I've just said, fuel on average represents 32% of an airline's operating costs. And in many cases, this is much, much higher, as I've learned during conversations earlier today. And in some airlines, it's over 50%.
And hydraulic systems, necessitating a different maintenance routine. Confusing the two aircraft's procedures, as happened at KLM, meant important safety checks on the 787's unique systems were either skipped or improperly conducted, increasing the risk of undetected faults in the fuel system. The refueling system itself is a highly complex network of pipes, valves, sensors, and safety devices operating under very high pressure. Precise regulation of fuel pressure and flow is critical to maintaining the aircraft's center of gravity and structural integrity, especially given the sensitivity of composite materials to pressure fluctuations. Even minor leaks or cracks near the engines during ground refueling pose a significant risk, potentially allowing flammable fuel vapors to accumulate in hazardous areas. Aviation history highlights the dangers of fuel system failures. The 1996 TWA Flight 800 disaster, caused by a fuel tank explosion due to vapor ignition, killed all 230 on board.
TWA Flight 800 exploded in the sky over the shores of Long Island. It was bound for Paris with 230 people on board. No one survived. The suspicion of terrorism was almost immediate. Many eyewitnesses described a streak of light heading towards the plane before it blew up.
More recently, a 2010 Qantas Airbus A380 incident involving an engine failure led to a massive fuel leak mid-air, nearly compromising the aircraft's control. KLM's discovery of the maintenance error prompted an immediate and precautionary grounding of all affected 787s to prevent a similar disaster. The operational fallout from grounding nearly a third of KLM's 787 fleet was severe. Flight KL685 to Mexico City was delayed by over 24 hours.
Airline customers are really struggling with the moment. We have a lot of people coming to Choice complaining about the fact that their flights are delayed, that their flights are cancelled without notice, and they're being stranded in foreign countries.
Stranding 250 passengers and causing widespread frustration. Flights to Chicago and Portland suffered delays ranging from 3 to 5 hours, affecting hundreds more travelers who missed connections and faced disrupted schedules. This created a domino effect across KLM's network and beyond, as passengers relying on Amsterdam as a hub were forced to find alternative routes. The airline's operations centers were overwhelmed, rushing to reschedule flights, source replacement aircraft, and arrange accommodations for stranded travelers. Many passengers were rebooked on partner or rival airlines such as Lufthansa, British Airways, and Emirates, inflating KLM's costs and complicating recovery efforts during an already busy post-pandemic travel surge. The financial consequences of the incident were substantial. Each canceled long-haul flight meant losing revenue from more than 250 passenger seats, plus ancillary income from checked baggage, onboard meals, seat upgrades, and other services. Average ticket prices for intercontinental routes typically range from $800 to $1,500, translating into several $100,000 lost per canceled flight. On top of this, EU 261 regulations require airlines to compensate passengers delayed over 3 hours with payouts between €300 and €600 depending on flight distance. With more than 650 passengers affected on the first day alone, compensation claims quickly escalated into the hundreds of thousands. Additionally, KLM faced the expense of hotel stays, ground transportation, and booking passengers on competing airlines to maintain goodwill. These immediate costs, combined with the long-term impact on the airline's brand and customer trust, posed a serious threat to KLM's financial health. The root cause of this crisis was traced back to the misapplication of maintenance procedures. While the Boeing 777 and 787 share some refueling components, their systems differ in critical ways. The 787's composite fuselage requires targeted inspections to identify microcracks, a task not covered by the 777's maintenance protocols. Moreover, the 787 employs advanced electrical systems for fuel management, unlike the 777's hydraulic-based approach. The incorrect use of 777 procedures meant that vital checks specific to the 787's materials and systems were omitted. Over hundreds of long-haul flights, with each lasting 10 to 13 hours, these gaps increased the likelihood of hidden defects forming and growing. Ground refueling, typically performed under high pressure to reduce turnaround times, would have exacerbated these weaknesses, raising the risk of fuel vapor leaks and potential fire hazards. This made the early detection of the maintenance error crucial. How much did KLM suffer for this hidden fault? What effect does this have on the vision of the Boeing 787? Curious? Let's get into it. Reputation, fallout, and long-term consequences for KLM and Boeing. The grounding of 7 Boeing 787 Dreamliners hit KLM's reputation hard. As a major member of the SkyTeam Alliance, KLM's problems didn't just affect its own flights, but caused issues for partner airlines like Delta, Korean Air, and China Airlines. Many passengers relying on smooth connections through Amsterdam faced cancellations and long delays. This put a lot of pressure on KLM's partners to find quick solutions, leading to confusion and frustration across the network. Frequent flyers, especially elite Flying Blue members and business travelers, were quick to speak out. These are the passengers who have plenty of other airlines to choose from and aren't shy about switching. Competitors such as Emirates, Qatar Airways, British Airways, and Lufthansa were ready to take advantage of KLM's struggles, offering their services to unhappy customers who felt let down by the delays and cancellations. What about Boeing? Do they share a portion of this blame? Sit tight. It's about to get more interesting. Even though Boeing wasn't responsible for the maintenance mistake, its reputation took a hit. The 787 Dreamliner had already faced problems in the past, including battery fires early on and cracks found in its composite materials. There were also issues with how some parts of the plane's fuselage were put together, which led Boeing to pause deliveries for a time between 2020 and 2022. On top of that, Boeing was still dealing with the aftermath of the 737 MAX crisis, where two crashes killed 346 people and deeply damaged the company's image. Because of these past troubles, any new negative story about Boeing's planes quickly grabs public attention. The news about KLM's grounded 787s was everywhere, with pictures of the parked planes making big headlines and sparking discussions online. Many travelers began questioning the safety of Boeing jets again. Concerns weren't only among passengers. Some former Boeing employees also said they worry about flying certain Boeing models. For example, Ed Pearson, a former senior Boeing manager, has openly said he avoids flying on the 737 MAX, despite Boeing's safety promises. Reports also showed that some workers on the 787 assembly line have doubts about the planes they helped build, with a few even saying they would never fly on a 787. This shows the trust problem runs deep inside Boeing. When people who know the planes best don't feel confident, it adds fuel to the public's worries. Fixing these issues won't just be about technical repairs. Boeing also needs to rebuild faith among workers, airlines, and travelers around the world. Inside Boeing, the pressure to innovate rapidly has sometimes clashed with maintaining strict quality standards. Employees working on the 787 program described intense production demands that occasionally forced shortcuts or overlooked some safety protocols. Whistleblowers and internal audits revealed moments where communication between design, manufacturing, and quality teams broke down, contributing to ongoing quality control problems. This environment not only affected how workers felt about their jobs, but also influenced how confidently they could stand behind the finished aircraft. When internal doubts become public, it undermines customer and passenger trust far beyond the technical details. The Boeing 787's cutting-edge technology depends heavily on flawless manufacturing processes, and even small lapses can cause cascading problems, making the stakes for maintaining rigorous standards incredibly high. The financial hit for KLM was also serious. Canceling and delaying long-haul flights meant losing ticket sales for hundreds of passengers, as well as extra fees from checked bags, seat upgrades, and meals. EU rules require airlines to pay compensation for delays, often hundreds of euros per passenger. KLM also had to pay for hotels, transport, and booking passengers on other airlines, which sometimes were competitors. Since many airlines are flying almost their full fleets to meet growing travel demand, KLM had almost no spare planes to quickly replace the grounded 787s. This made fixing the schedule even harder. Flight timetables, designed to be tight and efficient, became vulnerable to more delays and cancellations. KLM had to work fast to handle the chaos and avoid further damage to its finances and reputation. The problems at KLM show how complicated modern planes have become and how easy it is for mistakes to happen. The 787 uses advanced materials like lightweight composites and complex electrical systems that need special care. Confusing 787 maintenance with procedures for other planes, like the Boeing 777, can lead to safety risks and operational trouble. In this case, the mistake was caught before anything bad happened, but it shows how small errors can build into big problems over time. Airlines need to follow the right maintenance steps closely and watch every detail carefully. The technology in planes keeps getting more advanced, so maintenance teams must keep improving their skills and methods too. Both KLM and Boeing face long-term challenges. For KLM, fixing the damage means winning back the trust of frequent flyers and alliance partners. They will need clear communication and better reliability to convince passengers to stay loyal. Boeing still has to overcome doubts caused by earlier problems with the 737 MAX and the 787. Because airlines, manufacturers, and passengers are connected closely, troubles for one company can affect the whole system. The grounding of KLM's Dreamliners is a clear example of how small mistakes can have big effects in modern aviation. Maintaining safety and trust in this complex world is not easy and will require ongoing effort from everyone involved. KLM's experience with the Boeing 787 Dreamliner shows just how complex and advanced this aircraft really is. But how did the Dreamliner come to be, and what makes its design so different from other planes? Let's take a closer look at the history, design, and features that made the Boeing 787 a game-changer in aviation. The Boeing 787 Dreamliner's innovation, design, and challenges. The Boeing 787 Dreamliner began commercial service in 2011, promising a new generation of long-haul air travel. KLM added the 787 to its fleet soon after, attracted by its fuel efficiency and ability to open non-stop routes that were previously difficult to operate profitably. Designed to replace older mid-sized jets, the 787 introduced cutting-edge technologies and materials, making it one of the most advanced aircraft of its time. By 2025, over 1,200 Dreamliners had been delivered worldwide, reflecting strong global demand. Airlines like KLM use the 787 to connect distant cities with fewer stops, lowering operational costs and improving passenger experience. The aircraft's extended range and efficiency changed how airlines planned international routes, making non-stop flights possible on longer legs that older aircraft couldn't economically serve. This flexibility became especially valuable post-pandemic as airlines adapted to shifting travel patterns. A defining feature of the 787 is its extensive use of composite materials. Approximately half of the plane's primary structure, including the fuselage and wings, is made from carbon fiber reinforced polymers. This construction is a major shift from traditional aluminum frames, resulting in a lighter yet strong aircraft. The reduced weight translates directly into fuel savings and lower carbon emissions, aligning with increasing environmental regulations and airline sustainability goals. However, composite materials behave differently under stress and require advanced inspection techniques. Unlike metal, composites don't show damage through visible cracks as easily, so airlines rely on ultrasonic and thermographic scans to detect microcracks and delamination. This demands specialized maintenance training and equipment, increasing the complexity of upkeep compared to conventional aircraft, a factor critical to safe operations. What else do we need to know about this Dreamliner? You're at the edge of your seat, and it's about to get even better. The Dreamliner also incorporates aerodynamic improvements and new engines that boost efficiency. Boeing designed raked wingtips and smoother contours to reduce drag, while offering two engine options: the Rolls-Royce Trent 1000 and General Electric GEnx. Both engines are known for better fuel consumption and quieter operation compared to previous models. These enhancements allow the 787 to burn roughly 20% less fuel per passenger than comparable aircraft. This efficiency supports longer non-stop flights, a key advantage for airlines aiming to expand direct international routes. For example, KLM uses the 787 on transatlantic and other long-haul flights, benefiting from the aircraft's ability to carry passengers farther with fewer stops. Lower fuel use also helps airlines manage operating costs in a volatile energy market, strengthening their financial stability. Passenger comfort was a major consideration in the 787's design. Boeing introduced larger windows that dim electronically, improved cabin pressurization set to about 6,000 feet altitude instead of the standard 8,000 feet, and increased humidity levels. These features help reduce passenger fatigue on long flights by improving oxygen levels and keeping the cabin environment more comfortable. The cabin lighting mimics natural daylight cycles using LED technology, helping travelers adjust to jet lag. Additionally, the plane's quieter engines and enhanced soundproofing reduce noise inside the cabin, creating a more pleasant atmosphere. Airlines like KLM show these benefits as selling points, especially for business travelers and premium passengers on routes lasting 10 hours or more. These design choices reflect growing attention in aviation to passenger well-being on increasingly long international journeys. The 787's integration of advanced avionics and onboard systems further distinguishes it from previous generations. Its flight deck uses large touchscreen displays and enhanced flight management systems that provide pilots with real-time data for more precise control and fuel optimization. The aircraft is also equipped with advanced diagnostics capable of monitoring thousands of parameters during flight, enabling early detection of potential issues before they become critical. This proactive approach to maintenance helps airlines reduce unscheduled repairs and improve overall reliability. However, it also requires highly trained technical staff capable of interpreting complex data and responding appropriately. For KLM and other operators, investing in continuous training and sophisticated ground support infrastructure is essential to fully realize the benefits of the 787's technological advancements while maintaining the highest safety standards. The 787 program faced notable hurdles during its development and early operation. Delays pushed its initial deliveries back by over 3 years due to supplier challenges and complex systems integration. After entering service, safety concerns arose in 2013 when battery fires occurred in several aircraft, prompting a global grounding to address lithium-ion battery design flaws. Boeing made substantial design changes, including improved battery containment and monitoring systems, before returning the fleet to service. Additional issues with production quality, such as minor fuselage misalignments and composite material cracks, surfaced intermittently but were managed through repairs and inspections. Despite these setbacks, the 787 has maintained a solid safety record since corrections. This history shows the difficulty of introducing radically new technologies in aviation, where thorough testing and certification are essential before widespread use. Maintaining the 787 requires new procedures reflecting its composite structure and electrical systems. Unlike older planes that rely heavily on hydraulic controls, the 787 features an electrical system architecture, replacing many hydraulic and pneumatic functions with electrically powered actuators. This more electric design improves efficiency, but means maintenance crews need specialized training and equipment. Composites require careful monitoring with advanced non-destructive testing tools to detect hidden damage after each flight. The aircraft's fuel system and pressure controls are more complex than previous models, necessitating exact procedures during inspection and repair. Airlines like KLM must follow manufacturer protocols closely, as errors can lead to overlooked risks. The confusion between 777 and 787 maintenance routines that caused KLM's fleet grounding illustrates how critical correct adherence is for safety. The Boeing 787. Dreamliner continues to influence modern aviation by enabling airlines to operate longer, more efficient routes while improving passenger comfort and environmental impact. Its success depends on precise manufacturing, careful maintenance, and operator training to manage its advanced technologies. For airlines like KLM, the 787 represents both a technological leap and an operational challenge requiring exacting standards. Understanding the aircraft's history, materials, and systems clarifies why incidents involving maintenance errors carry such weight in the industry. What do you think KLM and Boeing need to do now to regain trust and avoid future disasters? Could advanced technology in planes like the 787 be a blessing or a risk for the future of air travel? Drop your thoughts in the comments. If you enjoyed this video, remember to like, share, and subscribe to our channel. Don't forget to check out the next video on your screen. You will enjoy it.